This tutorial shows how to download data from the Svan 958A in ground vibration mode and then present the data both as background data for ground vibration as well as the triggered logger data that we're going to use to compare to the BS7385 criteria. So if we start off by launching SvanPC++, of course this does assume that you have the software and the drivers installed for your instrument. If you haven't, then there are a couple of other tutorials on the SvanTech tutorial channel which will show you how to do this. And you can see that immediately I've got the 958A in the bottom left here connected, so we can get rid of that. And then this is the instrument wizard that you normally get at startup with SvanPC++, but you can disable if you want to. The first part is downloading the data. That's fairly obvious. The next is just to align the real-time clock of the instrument to the PC. Obviously if your PC is accurate, then that's a quick way of setting your instrument. We can also configure the device for remote connection to our Svan net service, assuming you have that remote control possibility. That is an option which is chargeable. And then the last thing we can do is to check to see if our instrument is up to date. We do continuously update instruments, and in fact one of the more recent firmware updates introduced this new ground vibration mode, which is the subject of this tutorial. So you can just click on that if you're connected to the internet, and you can see that this particular one is bang up to date. If it isn't, we recommend that you contact support@svantech.co.uk, and then they will run you through the procedure for installing the new firmware. But probably the first thing I want to do is to download the files. So this is now looking into the instrument memory, and on the left here we can see the files that have been stored, and on the right I've got the location of where I want to put my data. So perhaps I want to put it on my desktop, and I want to create a new folder, so we can call this Svan 958A GV data, and this might be the project name that you're working on. And now we can choose to download the data. So I've got some files here. These are the summary result files which have been stored every minute because that's what I put into the integration time of the instrument. But coupled with that, if I scroll right the way down to the bottom, I do also have a buffer file which is associated with the same data. So what I will just check here now is that I've got a buffer here which is dated 15th of June, and this corresponds to the summary results files that go from res 369 backwards to res 132. So let's just select the files that I want to download. So let's download everything from the 15th. So let's do that, and I'll take that buffer file as well. So let's just highlight that, and it helps if I press the right button. So let's do it this way. Now we can just press the arrow button here. Make sure that at this stage the merge button is not enabled, because this will merge the files automatically, and we'll do that afterwards when we open the files. So just click the download arrow, and it's now downloading first of all the individual files. These are the 1-minute files, and then it will download the buffer, which may or may not be large depending upon how many events you've managed to record. So it just confirms that it's downloaded 239 files. So everything's fine. So here are my files on my PC. We can now close that dialog as well as this one and start with a blank screen. So let's say open files. Let's go to the desktop and navigate to that particular folder. Now we can open these files individually and just have a look at a single 1 minute's worth of data, but probably what you want to do is to turn this into a 1-minute time history. So what I'm going to do is I'm going to select the files that I want to combine, and then I'm going to open them, Then I'll be asked, do you want to open them separately? Do not click here because it opens an awful lot of files, but I probably want to merge them. So now I can give this a name of 1 minute data, and it will now merge those files. It will give me a confirmation to say that all those single files have now been merged into one file, and then we can open up in the default time history display. So here we can see a time history. So these are the 1 minute files. I can configure this plot. I've got a cursor that I can move along. I'm just rolling the mouse wheel at the moment, which is moving the cursor along, and you can see the vibration results there. One thing you can do, notice that the scaling here is in meters per second. Most times for velocity we'll be using millimeters per second. So what I'll do is I'll go to the Tools menu and select Main Options, and then down in one of the various things that you can change here, you can change the value formatting. So let's just expand that, and under velocity we've currently got it set to meters per second, but I can change this to millimeters per second so that each time I look at vibration data it will show it in the right way. Now all I have to do is to close that and then reopen it, and you'll see now that my scaling is in millimeters per second. I'm currently having a look at the profile 2 of channel 1, and remember that profile 2 was velocity, so I want to take the peak velocity, or the PPV, in profile 2. So you can modify your plot there, and you can see now that I've got a much higher value in the vertical axis than I have in the other axes. And in fact this particular peak went up to about sort of 17 meters per second, millimeters per second, so quite a large impulse. You can see by scrolling the cursor along with my mouse wheel, you can see that that particular result was 17. So hopefully these will have triggered some interesting things in my logger. We can zoom in and out of this display. You've got various options up here for zooming in and out to get more detail, and so on and so forth. So these are all fairly standard functions for the now what we're going to do is have a look at that logger data so that we can take a look at the triggered data that we had into our logger. So if we just close the periodic data, go back to our file open dialog, and now open the buffer. So now this is the level versus time for the logger. You won't see very much here because we've only really captured a selection of logger data, which was obviously when it was triggered. So I'll close this display because it opens by default. You'll see now that there is an extra button at the top here called ground vibration. So if I click on this, it will open the new ground vibration display, and you'll see that I get an overview of the ground vibration values and also a graphical display which will show the dominant frequencies and the levels according to the vibration criteria. At the moment it's set up for DIN 4150, which is a German standard, so I can change that to BS 7385, and you should be familiar with the lines from the BS 7385 part 2 for the two different building types. Now you'll see displayed on this graph now, you'll see there are little spots, and each of these spots, depending upon whether they're red, green or blue, will depend upon the X or Y or Z axis, and then they are plotted at the dominant frequency. So you can see I've got a scale of 0 to 100 here. We've got 9 events which have been shown in this buffer, so I can step through those events, and then each time I go to a new event you will see that the points on the graph will be highlighted slightly larger. So you can see here, for example, the highest event that we had was that one. So you can see that in this particular case I had 17.378 millimeters per second in the Z-axis. The dominant frequency is given here, so in this case it was 6.5 Hertz, and it has exceeded criterion L2 in 7385, so that would be a particularly alarming situation. Similarly, the one below it, this looks like it's corresponding with the same event because I only had a logger step of 1 second, so you can see I've got the same peak particle velocities for these two. So for my reporting, I can now sort of change the graph to what I want. So if I wanted to highlight that, and then I've got all the normal tools for taking that out, perhaps to a Word document. So if we fire up Word, create a new document, and the results go into the Word document here. So there is a reported value for that particular exceedance. So that's a very quick overview on how to present the data from the ground vibration mode and compare to the BS 7385 criteria.